Now we have a Python example of time frequency representation. So it's a spectrogram. So here we have our imports. We are using PyAudio, we're using NumPy, SciPy Signal, Matplotlib. We've seen this before. We're using different threads, so we keep the audio part separate from the GUI. Here we have the parameters of our signal processing for the PyAudio. So we have the chunk size, number of channels, sampling rate, downsampling rate. So the format for the PyAudio stream, the number of FFT, and the overlap. Here we are designing a low pass filter. Actually, this is not important, but this is the same example as we've seen before for downsampling and upsampling, but I'm just repeating here. So we have just for downsampling and upsampling, there's a low pass filter. Here is the function to plot the spectrogram. So we have here, we read from the audio input into data blocks with length chuck. Then we have here, we can turn on the low pass filter on and off. We compute the array of a unit pulse train corresponding of downsampling rate of capital N. We do this here. We do the low pass filter after upsampling here. And here we play out the samples. Here is something to update the plot. Now we are defining our GUI. It's just a start button and a stop button, and then we can turn on and off the filters. So this is, we have already seen this example, and you can go back to the lectures to see this spectrogram in action. So here we have our spectrogram. I will start our example and see what happens. Hello, A, 1, 2. We can see here there's the time frequency representation. We can turn on
downsampling without the low pass filter, and we see all the aliasing components.
So we've seen that with downsampling without the low pass filter, we have all this aliasing. Now we will turn on the low pass filter. Hey, you can already see that my voice is downsampled. It's filtered. And now I will turn on downsampling and upsampling. Hello, hey, hey. We don't see the aliasing component, but we see much less bandwidth.
Hey, hello, hello.
Hello, hey, hey, 1, 2, test. But the goal here was just to show the time frequency. So we have time and we have the frequency displayed in this graph.